You place an order, it arrives the next day. No delays, no stock issues, no confusion. Feels like magic. But what you don't see is what's happening behind the scenes. A sensor on a factory floor halfway across the world flagged a delay. A pricing engine nudged your item just under your impulse threshold. A truck was rerouted at 2 a.m. because a weather model predicted fog on its original route, and none of those calls were made by a person. Today's supply chains don't just run, they anticipate, they optimize, learn, and adapt on their own. From the raw material to the moment a package hits your doorstep, global commerce is increasingly being managed by systems that never sleep, never blink, and never ask for a coffee break. This isn't some niche upgrade. It's a restructuring of how the world moves. And in this episode, we're going to break it all down. Not the surface stuff, the real mechanics underneath. How your products are increasingly managed by an invisible autonomous intelligence. How the systems that feed, clothe, power, and supply our world are changing fast. Because you didn't just place that order, it was already on the way. Chapter 1: The Invisible Brain Behind the Scenes. Picture a simple product, let's say a phone charger. You buy it online and it shows up tomorrow. But what had to happen for that to work? The copper came from Chile. The plastic was molded in Vietnam. Assembly took place in Shenzhen. Distribution was coordinated through a warehouse in Kentucky. And delivery was handled by a third party van that happened to already be in your neighborhood. This web used to be run by people. Now, it's run by something far faster, an interconnected decision engine that analyzes real world events in real time and directs supply chain behavior without waiting for someone to press a button. What's replaced traditional methods isn't just faster software, it's a way of operating that looks more like a living organism, always sensing, always learning, always adjusting. Let's talk about demand forecasting. In the past, it was all about spreadsheets. Last year's numbers, seasonal patterns, a little intuition, but that doesn't cut it anymore. Now, systems digest signals from everywhere: Google Trends, influencer mentions, TikTok product spikes, even local weather forecasts. A sudden rise in sunscreen interest in Southern California that triggers a shift in inventory distribution, a drop in iced coffee sales in Canada. Manufacturing adjusts before the surplus even exists. Walmart's Luminate platform does this at scale, blending historical patterns with real time customer behavior and inventory flow to predict exactly what needs to be on shelves at a given store. This isn't guessing, it's constant calibration. And it's not just what to stock, but where to stock it. These systems pre-position inventory closer to where demand is expected, cutting down both shipping time and cost. Amazon uses this approach aggressively. You may think you're ordering a phone case when you want it, but the system already placed that case in your region 2 days ago because it knew. Behind that is an entire physical infrastructure that's also being optimized. Inside warehouses, robotic pickers and automated shelves follow constantly updated layouts. High demand items are placed closer to loading docks, slow movers are rotated out, even the path workers or robots take through the warehouse is continuously re-optimized for speed and efficiency. At Ocado, a British online grocery platform, hundreds of robots move across a grid the size of a football field, coordinating like bees in a hive, all guided by a central system that calculates 10,000 movements per second. Transportation is another layer. In traditional models, shipping routes were static. Maybe they'd be adjusted quarterly. Today, it's different. Routes are re-evaluated continuously. A snowstorm in the Rockies? That triggers immediate rerouting. An accident on the New Jersey Turnpike? Trucks are diverted before traffic piles up. Some fleets are even moving toward full autonomy, like Einright's driverless electric transport pods, which means the delivery system itself is learning in motion. And that's not limited to highways. Maersk, one of the world's largest shipping companies, now uses predictive models to adjust port operations and container flow to minimize delays. If a ship is late leaving Singapore, arrival times and downstream supply schedules across three continents get recalibrated instantly. What ties all of this together is not just the intelligence, it's the invisibility. These decisions happen constantly in the background. Most customers never think about the complexity behind their same day delivery. They just see speed. They don't see the system that chose the supplier, tracked the inventory, picked the route, and coordinated the handoff. And most critically, they don't see how few humans were involved. What's running the global supply chain now isn't a team of managers working overtime. It's an ecosystem of connected, evolving, self adjusting decisions, quiet, relentless, and already one step ahead. Chapter 2: Beyond Speed: Systems that Adapt, Detect, and Protect. It's easy to be impressed by how fast things move now. Same day shipping, predictive restocking, personalized offers before you even search. But the real power of modern supply infrastructure goes far beyond speed. What makes these systems truly transformative is their ability to adapt, to sense disruption, mitigate risk, and ensure integrity without ever needing to slow down. Let's start with risk. The supply chain isn't a straight line. It's a sprawling, interconnected web, and when something breaks, the ripple effect can stretch across oceans. In the old model, one storm, one labor strike, one delayed shipment could derail everything. Now, those ripples don't cause chaos, they trigger countermeasures. These systems constantly scan global news, satellite weather feeds, maritime data, stock indexes, and even social sentiment. If a tropical cyclone is forming near Southeast Asia, inventory levels at affected ports are checked automatically. Containers are rerouted, backup suppliers are alerted, buffer stock is positioned in alternate locations, and customers? They never notice. It's not just awareness, it's action. What used to take a week of meetings now takes milliseconds. For instance, when the Suez Canal was blocked in 2021, many companies suffered weeks of delay, but others, including major logistics players, were able to reroute freight before it hit the bottleneck. Why? Because their systems flagged the risk early, not when the crisis was in full swing, but when traffic began building unnaturally upstream. Beyond shipping, these tools are also changing how we deal with breakdowns on the factory floor. Sensors embedded in production equipment collect streams of data on temperature, vibration, voltage, and speed. If a motor starts to run hot or a conveyor shows signs of slippage, the system doesn't just log a ticket, it predicts failure and schedules maintenance proactively before any product gets affected. That shift from reactive to preventative is saving manufacturers millions in downtime and loss. But it goes even deeper. Let's look at quality control. In traditional manufacturing, inspections were a mix of random checks, basic sensors, and human eyes. Problems were often found late, sometimes too late. But now, high speed imaging combined with learning models is being used to scan every product in real time, not a few samples. Every single unit. These systems can catch flaws invisible to humans, subtle warping, color inconsistencies, or micro defects in welds or circuitry. In auto manufacturing, for example, they're being used to inspect paint jobs and body alignment down to fractions of a millimeter, something that used to require slow manual measurement. But visual inspection is just the start. Today's smarter platforms also analyze customer return data, complaint logs, and review keywords. If shoppers across three regions start returning an item for the same reason, say a charger overheating, it doesn't take months to trace it. The system maps that failure to a specific batch, manufacturer, or material supplier. It flags it. Corrective actions start immediately. no PR disasters, no recalls making headlines, just a quiet fix in the background. That kind of closed loop feedback was nearly impossible a decade ago. Now it's part of daily operations. And while all this is happening, something else is emerging: accountability. Consumers don't just want fast, they want fair. They want to know where products come from, how they were made, and what impact they had. That's where sourcing transparency enters the picture, and it's one of the most important, least visible revolutions happening right now. Consider this: a single piece of chocolate might pass through 5 countries and 3 intermediaries before reaching the shelf. Tracking that journey manually is a nightmare. But now, systems can ingest data from suppliers, auditors, satellite imagery, customs reports, and local news to paint a live picture of supply chain integrity. If a farming cooperative in West Africa is flagged for using underage labor, that information is automatically linked to the buyers in Europe. If a textile supplier in Bangladesh suddenly fails a labor audit, orders are paused or rerouted before damage is done. These tools don't just protect companies from bad headlines, they enable them to enforce their values at scale, whether it's reducing carbon emissions, eliminating forced labor, or verifying compliance with environmental standards. Patagonia, for example, uses systems that analyze not just the direct supplier, but the supplier's supplier. They're building what's called a multi tier visibility map, which is now becoming the new benchmark in ethical sourcing. And we're not just talking about ethics, it's about trust. Because in a world where brands are judged not only by what they sell but how they sell it, trust becomes a competitive advantage. Customers remember companies that deliver, but they remember even more the ones that do it with integrity. All of this, the real time risk mitigation, the self healing manufacturing lines, the ethics engines running in the background, points to one truth: modern supply chains aren't just fast, they're intelligent, they're self protecting, they're self aware, and when something goes wrong, they don't panic. They reroute. Chapter 3: The Human Shift and What Comes Next. If these systems are doing the thinking, predicting, and even deciding, where do people fit in? The answer is closer to the edge, not removed but repositioned. The role of humans in the supply chain is changing, not disappearing. We're not here to input data anymore. We're here to question the outputs, to interpret, to decide where trade offs should be made, and maybe most importantly, to set the values the system should optimize for in the first place. Think about what that means in practice. A supply chain manager who used to spend days buried in Excel now gets a real time dashboard showing predictive demand curves, delivery risks, supplier scores, and inventory heat maps. But those numbers don't make decisions by themselves. The manager's job is now to decide: do we chase speed or sustainability? Do we go for efficiency or resilience? What's needed now isn't just operational know how, it's ethical judgment, cross functional thinking, and a deeper understanding of how automated systems actually work. And that's where the gap lies. Many professionals who've worked in logistics for decades now find themselves surrounded by platforms, APIs, predictive engines, and optimization models they don't fully understand. And on the other side, many of the engineers building those systems don't have deep supply chain domain expertise. Bridging this divide is critical. Without it, adoption stalls, resistance builds, and people revert to manual decisions, even when the tools are smarter. That's why the companies doing this well are building cross functional teams, pairing operators with data scientists, domain experts with system architects. They're not just training users to use the platform, they're training everyone to think together. But even with perfect collaboration, implementation is still hard. Let's talk about integration. Most supply chains weren't built with intelligence in mind. They're patchworks of legacy systems, spreadsheets, ERP, warehouse tools, and shipping trackers, none of which naturally talk to each other. Getting a real time view means pulling from all of them, standardizing the formats, cleaning the inconsistencies, and stitching it all into one seamless pipeline. That's months, sometimes years, of unglamorous work. And even after that's done, the biggest risk isn't technical, it's directional. Because once a system can act on its own, the question becomes, what goals are we giving it? Do we tell it to reduce costs at all costs? Then it might cut corners on quality or ethics. Do we prioritize delivery speed? Then maybe sustainability takes a hit. If we optimize for customer satisfaction, how do we define that? And who decides? These aren't abstract philosophical questions. They're the core design choices being embedded into automation today. And the danger is not that the system breaks, it's that it works too well at the wrong objective. This is why governance is becoming a priority. More organizations are building oversight mechanisms to audit how decisions are made, to verify that algorithms are fair, traceable, and aligned with policy. Some are even creating internal ethics boards for supply chain automation, not just legal compliance, but value alignment. Because as these systems grow more powerful, we face a new kind of transparency problem. When a decision gets made, can we trace it back? Can we explain why the system picked supplier A over B or rerouted shipment X through port Z? If we can't, then we've lost more than control, we've lost accountability. Now, let's zoom out because this evolution isn't stopping. We're moving toward fully orchestrated, self adjusting supply networks where edge sensors, Internet of Things, cloud platforms, and autonomous logistics work in perfect sync. A container tracked from factory to doorstep with real time location, temperature, and condition monitoring. If something shifts out of tolerance, heat exposure, a delay, a breach in packaging, it flags, reroutes, or alerts all automatically. In these next gen systems, the product itself becomes part of the supply chain brain. We are also seeing the rise of hyper personalized logistics. Not just 1 hour delivery, but delivery that adapts to you based on your schedule, your location, your history. No, you shop on Thursday nights, your next package gets routed to arrive Friday morning, just as you're home. And there's more. Blockchain is being layered in to create verified, tamper proof records of where goods come from and how they were handled. Machine learning is being paired with ESG scoring to help companies trace their emissions footprint across every supplier. Quantum computing is even being explored for ultra complex routing optimizations across millions of variables. The tech is accelerating fast, but as we go forward, attention grows. Because the more we automate, the more we delegate judgment. And the question becomes, who sets the rules? Who defines the trade offs? Who stays in the loop? And who fades out? It's not just about building smarter supply chains, it's about building systems that reflect the values we want to scale. Because once this machinery is in motion, it scales everything: efficiency, risk, waste, ethics, injustice, or integrity. The future isn't just faster and cheaper, it's also more automated, more opaque, and more influential than anything before it. So when your next package shows up right on time, and it will, pause and think, who made the decision that got it there? And do we still know who's driving the system? Because these platforms are no longer just tools. They're becoming the nervous system of the global economy, and they're only going to get smarter from here. Thanks for watching. Check out the references in the description to explore further.